the cloud. Okay.
All right.
All right. So we can't fully assemble the rocket because it is 12 feet tall and this room is about 8 feet tall.
Sounds like we need to poke a hole in the roof.
Yeah. Well, this building's going down anyways, so. But we do have a slideshow. How do I share my screen? Slideshow. All right. Okay, so here's the overview of our rocket. You can see there's the booster section, the sustainer section where the avionics bay is, the forward section that is also part of the transition into the 6-inch diameter section, and then the nose cone, which holds the payload. So then our booster and fin assembly works. So Eugene.
What kind of epoxy are you using?
The West Systems epoxy resin and the hardener.
It's the slow
105 is the resin and
206, I believe, for the slow hardener. Yeah.
okay. Yeah, I'm used to it. And it looks like you're filling it with something too.
Yeah, we're using the 406 colloidal silica epoxy filler.
Okay. That's stuff that I use, so no issues. That's surface mount, correct?
Yes, they are surface mount fins.
And then you've got a tip-to-tip overlay.
Yes, that's correct. So, do we have any photos of?
No.
So, for the layup, what we did was we had. Can you bring that back actually? Get nice and close. So we had, So we had one piece of layup that was going up one fin and down the other, and we did that for each 4 fins, and we had another one that was going from tip to tip on the inside. So we have 2 layers of that fiberglass layup, one going fully around the fin, and then one in between each fin.
Okay.
Does that make sense?
Yep.
Okay.
All right, and then the retainer is like oh my gosh, min diameter retainer that we have first epoxied in and then bolted in with 8 bolts and the standoff with the rail button. There we go. That's.
Are you still using the West Systems for the back retainer and the forward retainer?
No, those are with JB Weld.
Okay, good.
Steel reinforced epoxy. Yeah, we're using the steel.
Yeah, I'm familiar with JB, and the reason I'm asking is I'm not sure if you've ever heard of something called glass transition temperature for epoxies. But basically, a number of epoxies, they get up into the mid-100 F range, and they actually soften.
Okay.
So, it's such a minimum diameter. I don't have a lot of concern here. And the 2 parts that I'd be most concerned about, the motor retainers, you're using a high temperature epoxy.
Yeah.
Okay.
So I'm fine with what you've got.
Okay, great.
All right.
Did you have any more questions on the booster section?
At the moment, I would say no. Do you have any pictures? Okay, so the only other question on the booster section is, I'm trying to remember your drawing, is okay, so the sustainer stays attached to the booster?
No.
Where's the separation on that?
Between the yellow portion, which is our drogue chute, and the avionics bay, which is that like metal middle part.
The grayish area?
Yeah, so the grayish areas are avionics, the yellows are parachutes.
Yeah.
Okay, so my one question is, how are your shock cords attached to the booster section, since we're talking that right now?
There is an eye bolt. I don't know if you can see down.
I can see something in there.
There's an eye bolt that's screwed into maybe the flashlight.
Yeah.
It helps a little bit. So the details I'm looking for on the eye bolt, first off, is that a forged okay. Is that a forged eye bolt?
Yes, it is a forged
from
eye
this
bolt.
view.
Yeah, so it's
Can you, I don't know if you can hold it, okay,
yeah, so I couldn't pull it out, but it does it doesn't have a gap in it or anything. It's not like the hook
okay,
goes
it's not a bent wire, is what
correct.
I'm
Yes.
getting at.
Yes. It's
Okay,
fully
so
solid.
it's all one continuous loop,
Yep.
Yes.
okay. And does it have any retention to keep it from screwing out, like Loctite or no lock nuts or anything?
We have lockers on the bottom of this.
In the retainer? I don't think we do.
I mean, the bottom of that eye bolt is the same thing that the motor casing.
Holding the motor in?
Yes.
Okay,
So we don't have any additional retention because when we screw in the motor casing, we'll also be tightening that.
okay. I'm good with that.
Okay. That is the Aerotech 98 mm.
Okay,
That's all cots.
you're good.
So then here are standoffs, which you saw it's here. So this
Yeah, I think
one-
we exchanged some emails because there was some concern about positioning.
Yep.
Yes.
So I don't know if you have any questions, but it's 1/4 inch aluminum and 1/8 inch like thick going out of the rocket.
You can see. Try and get a look at the cross section. there.
Okay, that looks good.
Okay.
That
And
goes
then
all the way around and you got the same thing up forward.
it's slightly different up forward here.
Okay, how is the block attached to the booster?
So we have a bolt going fully through this and then retained on the inside of that
Retainer.
of that same motor retainer.
Okay, and all right.
Yeah,
So
in
there's
addition to that, it's
nothing,
also JB welded on that surface that attaches.
okay, nothing on the inside there where the bolts come through that's gonna snag on any of your recovery stuff.
No, that is protected inside the retainer. So
Okay,
like on facing the motor.
Yeah, all of those bolts are going to be under the top cap of that like eye bolt.
okay,
Because it's
Good.
all, yeah. Alright, here.
good. Looks solid so far.
Okay, perfect. Do you have any other questions on standoffs then, or?
Not on the standoffs and the booster and the like all seems reasonable. I assume you're gonna be painting it and the like if you haven't already. No, you haven't, obviously. So, one recommendation is keep the colors light out there. It gets hot out there.
Yep.
I think your team's been out there before.
Yeah, last year was our first year, and I think we're gonna bring in an aluminum blanket this year too, so that it
Okay.
keeps avionics and stuff cool.
Yep, paint it light.
Yep. And then,
Okay,
so going into the
so-
avionics bay,
so it looks like it's a triangular sled.
yep. So the inside is hollow so that we can put the wires in there. And it attaches to the booster with this coupler that is attached to the air brakes that that stick out here. So this is the air brakes, and then the rest of
Okay.
the avionics bay is up here.
And I think I asked the question, can the air brake act independently? And I think you answered that and said no. If I remember, can it work asymmetrically? The air brake.
Oh no, it cannot work asymmetric.
Yeah, I think you've answered the question. I'm just
Yeah.
going back.
Yes.
Okay. All right. So what I'm looking at here, I guess let's start at the upper left. So that's like looking down into the.
Yep, that's this way down if the bulkhead wasn't here.
Okay. All right. So then the next photo below it.
That is the servo motor, which is a Lion 2000. And that was recommended with this motor.
Okay. Is that a pillow pack type or is it metal or what kind of construction is it?
It's a 4-pack, like a combined pack of the 18650 lithium ion
Okay,
cells.
so they're basically metal batteries in a pack.
Correct. Yeah. Yes.
Okay. And how are they actually retained within that squarish enclosure?
Yeah, so you can see here there's a little like adapter that sits in or on top of the battery, and then those are screwed in around into the rest of the.
Okay, I think I see it there. So it
Yeah.
can't go in.
Show it
Is there a recess or something it goes into so it
Yeah.
can't move side to side?
Yep.
Yeah, it's hard to see on camera, but it does fit into a recess, and then there's also this screwed in piece that holds it down from the top.
Okay, so it can't go anywhere. That's what I'm at. That's where I'm going.
Yep.
Yeah, it's not going anywhere.
Okay, and that battery is strictly for your altitude system.
Well, like,
Okay.
yeah.
Yep.
Okay, so let's go on to the
Wait,
just left of middle.
So these are the switches that we're using, and it goes primary, redundant, GPS, and I have it in the speaker notes.
Then it's the air brake system.
Oops. Is it?
Yeah.
Okay, yeah. Yeah, primary, redundant, GPS, and air brakes. Yep, that is correct.
Okay, so how are they accessed on the pad?
So we're gonna have an avionics door that is like a hole cut out of the rocket with an aluminum sheet that closes, and then we can just switch it on the pad and then screw that door back in.
Okay. How easy is it to move those switches? Is there any concern that any flight from orientation standpoint, you're perpendicular to the primary loads? Is there any concern that any vibration or anything can move those switches accidentally?
I can answer that. So all of these switches, they all are oriented the same way, so that once they're flipped on, we're going to have a hold down bar that will rest across all of them that we're going to screw in place. So once
Okay.
all of them are switched on the pad, that bar will be put in place, and then none of them will be able to move at all.
So you're gonna lock them on, basically?
Yes, correct.
Okay, the only concern I have with that is it doesn't look like you've put the provisions in for the bar yet
Right.
on the photo. Remember, you're gonna be out there on the pad. Rocket's gonna be vertical. So a suggestion is whatever fasteners and stuff you use, try to keep all your fasteners captive. Because the last thing you want to do is drop a small fastener while you're at the launch pad.
That's a very good point. Yeah. We'll make sure to note that.
Yeah.
Yeah, keep your fasteners captive where possible.
We're planning to have a box of extra of all the hardware in the rocket as well with us. So
Yeah, but it's still nice because you also don't want any foreign objects within the rocket. So if you drop one, guaranteed it's going to go where it's least accessible.
definitely, yeah.
So that's why it's good practice to keep the fasteners captive if you can. Okay. All right, so that's to be seen still. Do the switches light when they're energized? Is that what the red is?
So our current plan is to have them to light on when they're energized. That power will be provided through a separate battery from all of the other systems. So we're not going to be tapping off of any of the avionics power or anything for that. And we also have a version of switches that don't have a light if we decide to not do that.
Okay. Do you show that on your schematic? Because someone's liable to ask there, it's going through all the switches. I'm not concerned from a redundancy standpoint if that's all that one battery is providing is just lighting the lights. But keep in mind that you could be questioned on that. On your schematic and the like, you may just want to show that if you've got one battery there, that it is truly independent of all the other electronics. All it's doing is powering indicator lamps.
Yes, I do believe we have to update that on our schematic. But
Okay. because you could get challenged on that when you go through. There's no guarantee that I will be the person doing the inspection
Yeah.
at stack. So you'll have potentially a whole new set of eyes that you'll have to explain this all to again.
Yeah.
Okay.
And then we can go back
Okay,
to
let's go back to the pictures. Okay, so it looks like the third from the right is the stack, looking on the switch side. Is that correct?
Yes.
And looks like a telemetrum on the bottom there. And I don't recognize the top one. I don't memorize them all.
So on the second photo from the right,
Yeah.
the bottom it's actually a featherweight GPS altimeter.
Okay. All right.
Top one on that side is what's our backup avionics? That's the
No, this one's ours.
it's we're using two different brands of altimeters this time. So
Okay.
backup altimeter. What type is it?
You can check.
Yeah, that's an Ontacore altimeter.
Okay. AIM USB of some flavor.
Yes, I believe that's correct. Yes.
Okay. Have you powered that? Okay. Only reason I'm asking is I did a level 3 cert about a year and a half ago. Individual was using a USB, I think it was the 3.0 from Anticore. And when it got powered up, it fired a charge. And he contacted Anticore because it was behaving funny. And it turns out that there was a tolerancing problem with the board. There was a design issue, basically.
Okay.
So if you haven't put any power on this yet, I suggest that you do so and exercise a lot of caution during the initial power-ups.
Okay.
Okay. Yeah, we'll definitely have to test that out and ensure that our device is not doing that.
Yes.
That is, we decided to use a separate altimeter as our backup, just for increased redundancy. We do have a lot of experience with our primary altimeter, which is the MissileWorks RRC3. So, yeah, that we'll definitely make sure to test out that backup altimeter.
Yes. So you don't have any wiring yet. Are these pictures all basically current right now?
Yes.
Okay. So you still have wiring to do.
Correct.
Okay. All right, let's look at the next picture and let's see what I can do here because right now there we go. I can move your picture. I've got just some desktop issues here. Okay, so this is the opposite side. This is the RRC3.
Yep.
Okay. So I see are the components mounted on standoffs? Or are they laying right hard against? Are they just bolted hard against the sled with the joints and stuff against the sled?
Right now they're not yet on standoffs. We intend to put standoffs on there, or at least spacers, because we have heat set inserts into the plastic. So right now they don't have a standoff, but they are raised above the plastic. We will be putting spacers in that and probably some rubber ones so they have some give. And yeah, they will be adequately spaced off of the plastic to ensure that no bending is occurring.
Right. Well, because what I look for when I inspect is that you're not actually resting, that you're not twisting or bending the board, and that you're not resting on your circuitry.
Yes.
Okay. So what I don't see in any of these pictures, unless it's a coming picture here, is battery installations.
Yeah, we do not have a picture of that quite yet. But for everything else, it should be mounted similarly to these.
Are the batteries going on, I'll call it the upper part of the sled above that middle aluminum bulkhead, or are they going below that aluminum bulkhead?
I don't know either.
You'll have to excuse us. Our avionics lead could not make it to the meeting tonight. So we're a little rusty on our knowledge here, but I believe they're going in the upper section where the altimeters are, just to avoid having a wire going through. I can say, as far as the batteries go, thought we had one.
9 volt.
Yeah, we're just using their Home Depot brand 9 volts, which we've pulled apart and made sure that they are like a solid cell. They're not just like the combined type, so we're confident that they're not going to have any issues flaking out during flight.
Okay, my concerns, since I don't see it here, are one is how solid that you mount the batteries, whether you're building some kind of, I'll call it a cage to keep the batteries stationary during flight, how you're orienting the batteries. Generally, practice is to put the batteries where acceleration forces force the batteries onto the connectors.
Yeah.
I don't know if you're using I'll call it the transistor radio connector, or you're using a battery holder.
Yeah, so
Okay, those are I call it transistor radio connectors.
Yep, those are the connectors we'll be using. So in our rocket last year, we had it velcroed to the avionics sled, and then had a vertical zip tie and a horizontal zip tie. Which
that will work. I'm not a big fan of zip ties for holding batteries in place. It does work. Make sure you cinch them down nice and tight.
Yep.
We're
and
gonna
Velcro should keep it from sliding around. Either that, or use some instead of Velcro, if you want to be a little bit more solid, two-sided tape.
Okay. Yeah, we'll be looking into our attachment and making sure that they're very solid.
Okay, and making sure that the connector can't come off. So you're using 9 volts for your deployment devices, and you're using the pillow pack for the featherweight.
No, the pillow pack is for the motor. The featherweight will be a lipo that is recommended for that we've used in previous years as well.
Okay, I think that's what I call a pillow pack. Yeah.
Yeah,
okay.
this is one of that's the battery for the featherweight.
Okay. And again, one of the things that most inspectors, definitely if I see the rocket out there, going to pay a lot of attention to battery mounting. One thing I could send you, I did put together a PowerPoint presentation of things that are typical hits during the inspection.
Okay, yeah, that'd be
excellent. And I can't know for the wiring and things like that. I can send that off to you.
Yes, please.
Okay. So far, I don't see anything that bothers me.
Okay. Do you have any questions?
Again, be aware that the battery is one area where people do get in trouble.
Yes.
Okay.
So there is our wiring diagram.
I don't think this has changed since your report, but I'm just going to take a real quick look-see here. Okay, where is the SRAD GPS mounted? I see, because there's only 3 modules up there. So you've got the fourth item, which is the SRAD GPS. Where is it located?
That would probably be located, it'll be in the bottom because it does control the air brakes. So that will be in either this area or mounted on the other side, on this side.
Okay, and what about its battery?
Similarly, like also in here, it's also using a lipo pillow pack that was recommended by the manufacturer. So I think those both should be in this little area right here.
Okay. All right.
Okay.
Next. So then here's our air brake systems.
Okay, so basically a central gear that works all 3 brakes at the same time.
Yep.
And then you're using the GPS for your logic for deployment.
Yep.
And I'm guessing you got some kind of, it looks like some kind of a dovetail or slides there that the system works on.
Yes.
Okay.
Yeah, you can see a little close up the cross section of that air
Yeah,
brake.
I see it in the right-hand photo here, so I'm good
Oh,
with it.
Okay.
Um,
And it's held in with 6 bolts, I'm guessing.
um, yeah,
Like to the airframe?
Yeah.
Yes. 6
Okay.
bolts on either.
So the one question I'd have to go double check is, since it's a permanent joint, I have to go look at the D-Take just to make sure that, you know, at this point in time, I don't see a problem with it. It could be a question about, the length of the coupler there. But
Yep.
that's a permanent joint, it's metal. I'm good with it.
okay.
Okay.
Okay, keep on going.
So then here is our transition. Walk with me. It's fine. So here's our 4-inch section, and then that is attached with a transition that we designed, and then it has fiberglass layup and then dolphin glaze. Our 6-inch section connects to some bulkheads here that are screwed into place and epoxied into place.
So
And
if I
then-
remember, the 4-inch tube goes up through the transition into the 6-inch.
Yes,
Yes,
that
this
is
is coupler right here, so the body tube for the sustainer goes around this. And then that goes all the way up until the metal bulkhead, which is here.
which is also screwed in.
Yes.
So basically, the transition is not really load bearing, it's more just aerodynamic.
Precisely, yes.
To ensure that this section is rigid, because obviously you've got a lot of drag coming in from the nose cone. So what we did is we've got 1.5 times 1.5 calibers, 1.5 body diameters of length on either side. So we've got 6 inches on the 4-inch side of tubing that actually extends into the 4-inch section. And similarly, we've got 9 inches cross over the 6-inch section.
Okay.
One centering ring at the bottom and then one at the top.
By the way, just out of curiosity, the other gentleman that's on the video here, is he the advisor or the mentor or the flyer of record?
All of the above.
Yeah.
Okay.
Yes, I am.
Okay, so you're flyer of record for this.
Yes.
Okay. Yeah, you're doing what I expect you to do, is be the fly on the wall, but just curious. So thank you.
Yep.
Okay, keep on going.
All right, so then here's like the inside view, because you can't see it with the nose cone. But so here are the bulkheads. This top bulkhead has a little recessed portion where the payload will fit. Yep, right here. So if you can see into it.
Okay, so it's a 3U, and you're kind of basically piloting the payload into that recess.
Yes. And then it'll also be secured with these
Okay,
rods.
We have a cap that goes on the other.
okay. And your payload stays with the rocket.
Yep.
Okay.
Do you have any other questions on that then?
So far I'm good. So just to make sure, the picture on the right here is the top of the transition section.
Yes.
Yeah, so what you're the bottommost in that photo and the second from the top bulkheads, those are now fully epoxied in place inside that tube.
As well as screwed in.
Yeah, also screwed in through the airframe, bolted in place. So we're confident those aren't going anywhere.
Okay.
But yes.
Okay. Keep on going.
All right, so then here's the little payload, I don't know if you need an overview of the payload or not.
All I'm worried about for the payload, and if I remember, you guys did a real good job on safety for this, because I think you had some laser aspects in here.
Yes. So previously we talked about having the laser markings for the direction of the laser and stickers just saying that there is a laser on there. We will still be having those markers on there. However, now we are using an LED instead of a laser, so it won't have the same like safety measures necessary, but we're still going to keep those going just in case and to
Okay.
make sure people know that there's a live experiment going on.
Okay, so my concerns are basically, one, are there any hazards inherent in the payload? And one of them, of course, as you mentioned, the laser. The other part is you're not ejecting it, which is good. Any high voltages in the payload?
Highest we go is 12.
Okay, no issues there. When I would think of high voltage, I'm thinking over 50.
Yeah, definitely.
So no issues there. Do you have any RF? Are you broadcasting from the payload?
Nope.
Okay. So basically, unless the payload for some, while you're handling the payload, or for some reason it breaks open, there's no basically hazards of the payload.
Nope, there should not be.
I'm happy.
Awesome.
All right, so then moving on, here's the nose cone. That's just the rest of it, which you saw. So that's just a COTS 5-to-1 von Karman. And that is
Okay.
screwed into the sustainer through with these.
We have T-nuts that are epoxy inside and
Yeah.
then sanded down, and then we have cut holes through both the nose cone and the coupler tubing to secure that in.
Okay.
I don't know if you can see that very well.
So, yeah, we're using like these T-nuts. We're epoxying those in. Those would be from the inside. So, like this, and then we would Dremel off that top bit. So, then we just have that through the wall attachment. And that would be JB welded in place.
Okay.
And yeah, and then we just install the bolts through those 2 layers of fiberglass and into that T-nut.
Okay.
So you can see that hole and the shadow of the T-nut in there.
Yep.
I believe that is all we have then, and then
So what I
Um,
don't see any presentation on your recovery systems.
okay, those are so we're using basically the exact same thing as last year. We have a 30-inch drogue and what's the length of the main parachute?
It's a 12-foot high drag, I believe CD 2.2. It's from Rocket Man.
Yep.
Parachute. It's the same one we used last year, and we have a similar weight, so we're confident that'll have the same descent trajectory.
Okay.
Same drogue as well, yeah.
And then
So
no
what kind of, without me going back to your reports, what kind of rates of descent are you looking at?
Under main, I believe it might be even under 15 feet per second, but it's right around like that 13, 14
Okay.
feet per second.
I
Under
don't remember flagging anything on it during the review. I can go back and look at it, but I think that was okay during the second report review.
I'm pulling a number. I want to say 90 feet per second under drogue.
Okay. Have you packed your parachutes at all to make sure you've got enough room and everything fits in there?
We did some preliminary packing before we cut our tubes to length. Just like packing the parachute and checking with the shock cord, just like as a dry run. We haven't done that fully assembled yet, but we're planning on doing that shortly for our ejection test as well.
Okay, so you have not done ejection test yet?
Correct, yes. Our launch got scrubbed for the end of April, so we got set back a little bit.
Okay.
We do have our packed lengths for reference from last year though, so we are pretty confident everything will fit fine. But we definitely do need to test pack it. as far as shock cord goes, we're using 5/8 inch tubular nylon webbing that's just purchased from REI. And we're going to be we'll have the full write-up on all the different lengths will be in the technical report.
Okay, one thing is make sure, dealing from REI and company, make sure that there's no splices. I think sometimes they're labeling indicates that there could be splices.
Yep. No, I
some
made
of that
sure
bulk stock.
not to get like one continuous rope.
Yeah, just make sure.
Okay. Yep.
Yep. Okay,
And then we have our checklists.
that's something I was gonna ask about.
Yeah. Launch checklist. If it loads. So here is like prior to travel, builds like
Let's go back. Okay, so a couple things. Okay, prior to travel. So one thing that you probably want to do is if you don't have it here yet, is make a list of all the tools and everything that you need.
yeah, we do have that still from last year and the tools haven't changed.
Okay, and all your personal protective equipment.
Yes.
Okay, you may want to correct it too, because you're mentioning the two RRC3s there.
Yeah, we have to change that to the RC3 and the and
Yeah. After what you said about that Ontacore, we're
little
might
concerned.
go back to having two RC3s, but we'll definitely make a final decision on that shortly.
Okay, like I said, I had a bad experience with one.
Yep.
And all I'm saying is, be careful.
Yeah.
Until you have confidence in the unit.
Definitely.
Yep.
Okay, let's go back up just a little bit here. Okay, because one thing that, again, if I were doing your inspection out at the field, one of the things I will have you do is, again, like to have the rocket presented, ready for flight. No pyrotechnics or anything installed. No energetics.
Mm-hmm.
And then what we'll do is like I said in my email, is basically go through the sequence, have you separate the two parts, pull it apart. I want to see how the parachute plays out, that everything essentially falls out. So that's what I would be looking for the whole rocket there. All right, avionics bay. So one thing question on your avionics bay is just a couple things looking at your checklist. One, where are you verifying that you've got fresh batteries, or you're checking batteries for voltages?
We will add that.
Yeah, make sure that you've got either fresh batteries or charged batteries.
Yeah, in the past, we've just only taken them out of the packaging to use them, and if they're not in packaging, we just assume they're not good.
Yeah.
Right.
But yeah, we'll definitely include that on the checklist.
Yeah, even when you take them out of the packaging, be careful, because you can have them where they put out 9 volts with no load, but be careful because sometimes you get a flaky one, and if you can test it under some load, just to make sure that it doesn't drop too low.
Do you have a method of doing that? Like a good way?
Basically is you get figure out a resistor that represents a load on there, or at least if you don't have a representative load, hook it up to your electronics. No pyros installed.
Yeah.
Don't try to fire the electronics, and at least with the electronics just in their idle state, just make sure the voltage is good while you're in the idle state.
Sure. Yeah, that'd definitely be good to add.
Okay, switch wires. Okay, the switch wires are not soldered into the switches. I'm looking for avionics bay. Insert switch wires into switch terminals.
Well,
that might be from an older revision of this checklist, back when we did not have the switches like able to be fully assembled, like they had to be switched in during assembly. We no longer have to put those switch wires in. they're just gonna be into the like avionics using the screw terminals on
The terminal blocks?
Yeah,
Okay, so one thing just to be that I look for is when you insert the wires, make sure there's no exposed conductors at the terminal blocks and that you do your pull tests.
yep. Yeah, I think we're even considering putting some super glue on them for the final flight, just to be sure of it.
Be careful because if the super glue wicks, you could actually be creating an insulator on there.
Oh, okay.
I'd be careful with that.
Okay. Yeah, fair enough.
So black powder charges measured. Again, you may want to, in your checklist, put down what your charge sizes are.
Okay, yeah. We're gonna figure that out more once we do ejection tests, because we
Yeah.
have the preliminary, like, charge.
Okay.
but yeah, has to be double checked. Also, I think I packed that before we left last year.
I'm just reading through it a little bit.
Mm-hmm.
Okay, you can go on next page. Okay, the motor stuff. Okay. Okay, so you have your shear pins. Do you have any vent holes for your parachute compartments for the altitude that you don't separate from pressure?
I don't believe we've drilled those yet.
Okay, do you plan to have vent holes for your parachute compartments?
Yes, we do. Parachute and avionics compartments, yeah.
Oh yeah, definitely, because if you're sensing the outside,
Yeah,
you
yeah,
better
yeah.
have vent holes. Okay.
And then the motor assembly, I know last year we went to the like one hosted by Wildman, so if that's a thing again, we'll probably go to that.
Sounds like a plan.
Yep. Yeah, and then we have experience with that motor assembling, so we're pretty confident.
Yeah, we are using the exact same motor as last year.
Are you going to verify your battery life on your electronics, or do you have enough experience with them to know?
So, what was the question?
Electronics.
Are you going to verify your battery life? I mean, there's always a possibility you could be sitting on a pad for well over an hour.
Yeah, so last time we were there for I believe 6 hours waiting. And we definitely found the limits of our battery life then. We're planning to do a life expectancy test again before launch. But with all our calculations and experience this far, we're very confident that we'll be able to they'll be able to last for the flight.
Okay. All right, keep on trucking. Okay, you made sure, by the way, that your arming door is not on the same side as your rail buttons.
Yes.
Yeah.
Okay.
We haven't cut the hole yet, but we will definitely be making sure of that.
Yeah, well, there are people who have missed it.
Yeah, definitely.
So, okay, one suggestion, and it's purely a suggestion, is as you arm your electronics and altimeters, you may want to just put either as a appendix or within the text here, or at least what is the expected pattern that you've got. No, the beat pattern.
Yes.
Oh, yeah.
Yeah. I don't know. I guess that might not be on this one. I know for a fact our checklist last year it did definitely have like the beat pattern listed for each one as we go in sequence. But yeah, I agree. We'll definitely have that.
Okay. Okay, so all right, your flyer of record is going to do the final connections to the igniter. Okay, so one thing I don't see here is what is your procedure if for some reason we have to pull you off the pad because either weather goes to pot or you have an issue for whatever reasons. or for
Right.
some reason the window closes before you fly, do you have a procedure here to safe the rocket if it's coming off the pad?
We haven't written one yet, but that is planned, to have like a complete disarm procedure, in the event that everything is armed and assembled.
What I would call it is a scrub procedure.
Yeah,
Scrub
sure.
procedure. That's good.
So yeah, and just making sure that that's all done safely. We'll get that made.
They'll go over it with me.
Okay, great. Okay, keep on trucking here. Okay, so one thing I don't see in this section here for post-launch and recovery, I don't see anywhere that you're verifying that there's no live charges in the rocket.
Okay. How would we go about like verifying that there isn't, other than like
Okay,
open?
one way of doing it would be to, if you're taking your phones out there with you, either a mirror to look down the rocket so you don't put your face in front of it, or put your phone down, snap a picture and look at a picture
Okay.
so you can see if all the charges are fired.
Okay.
But the question here is, immediately disarm all electronics. Okay, I do see here, check the charges are discharged. So again, you want to think about, so it is there. Think about what you want to do as far as charges. I mean, they're deep inside. If you safe your electronics, it should be safe to carry. If you want to pull your tape and dump the powder out there, I'm okay with that. Depends
Okay.
upon accessibility.
All right. Yeah. We will put a procedure in there to look and verify if they're.
Yeah, you've got it here, actually. Check that charges are discharged, check motor condition. So
Yeah.
you actually do have it here.
We'll just say how to do that safely besides sticking your face down the rocket.
Yeah.
Yeah. If nothing else, if you're going to stick your face in there, put a face shield on.
Yeah. Okay.
Yeah.
Okay. Igniter. Okay. All right. Keep trucking. Okay. All right. I like your checking for animals there. Okay. So what I'm going to do here right now is I'm just going to go look at the check. I'm just going to go through the checklist that's been provided to me.
Okay.
So, all right. So I'm looking through the nose cone right now. Shoulder length, 0.5 calibers or greater required. I think you had that covered. You had shear pins on there. Actually, yeah, you had shear. No, the nose cone is permanent.
Yeah, the nose cone is permanent.
Okay, so it's not going anywhere, but you have stuff in the nose cone.
Yes.
Okay.
And it is maybe worth clarifying the nose cone doesn't actually have anything attached to it. The payload is contained within like the transition upper sustainer section, and the nose cone is just capped on. So we're not worried about the nose cone falling off or anything because it basically only has its own weight.
Okay. Are you using swivels on your recovery stuff?
Both drogue and main.
Okay, good. Are you using deployment bags or just blankets, or are you using wadding?
Nomex blankets and the cord protectors as well.
Yep.
Okay, good.
Also, yeah, if there is extra space, using like that recovery wadding.
Okay. You're using all just BP for deployments.
Yep.
What are you using for your shear pins?
440 nylon shear pins.
Okay. And of course, you're gonna have those installed when you do your ejection tests.
Yeah, we were planning on testing just exactly what powder masses we need to blow those. I think we were planning on using 6 of those 440 pins around the circumference.
Okay, that sounds a little heavy, actually.
So we did have an issue of an early separation last year with only the 440 shear pins. So that was what we were hoping to do with the ejection test, is see if using 6 instead of 4 would maybe achieve a better result.
Did you put the main out at Apogee last year?
Yep.
Yep.
Okay. Yeah, the only thing is keep that in mind because you've got a fairly small diameter rocket
Mm-hmm.
for your ejections. I forget the exact shear force for a 440. I want to say it's like 40 pounds. So 6 of them, you're going to need to develop 240 pounds of force just to overcome the shear pins.
Mm-hmm.
And if you're 4-inch diameter rocket, you only have about 12 square inches working for you. So you're going to be working with a relatively high pressure recovery system.
Yeah. I think we were going to run calculations and figure out if that's a feasible pressure, like you said, and consider based off of that decision.
Yeah, run your calcs, and do your testing.
Yes.
I mean, yeah, it's hard to know if we'll have that same behavior at Apogee, without going to 10,000 feet ourselves. But, yeah, we're going to do our best to make sure that we don't have that same issue.
Okay. Okay. I'm just looking through the checklist here. And everybody has their TRA numbers that's going down range.
Yep.
Okay. And of course, you've got your flyer record.
Yep.
Again, just to remind you, temperatures again, because it will be hot out there. Again, also because the temperatures you're testing in right now, just keep that in mind. What the fit is when you're testing, because I'm assuming Wisconsin is probably what, 70 right now?
Yep. I think exactly.
Okay, so things can change when you get down to 110.
Yeah.
So just keep that in mind for your fit when you do your ejection testing. You may want to double check your fits once you get out to the field, and if you have to, do another ejection test.
Okay.
And for the temperatures down there.
Okay. Yeah, we could put that on the checklist just to see if make sure our fit.
Just be attentive to the fits of things, because again, it's going to be much hotter than you currently have.
Definitely.
Okay. Do you have anything else to present?
No, that's all we got.
Okay. So I don't see any showstoppers. My biggest concern is not being able to look in this review at the battery installations, the wiring, and of course you haven't done your ejection test. Have you done any testing, subscale or subcomponent or anything?
We have not.
Okay. And what, other than ejection testing, what do you have planned?
We want to try to get out and do ejection tests this week, because then the next available launch is May 25th or 26th.
Okay. So my last question, and I'm going to address this to you and to your flyer of record. And my question that I always ask is, because I used to have this addressed to me during flight readiness reviews, is what keeps you awake at night on this rocket? Is there anything in particular that you're worried about that keeps you awake at night?
I know I'm worried about the mass, and I think a lot of us are.
Just that's
Okay. Is there anything that you've done relative to that to sleep better?
We weighed it, and our components all line up with the Open Rocket Sim, and the Open Rocket Sim says we will be going more than 10,000. So
Yeah, we might not have the chance to use our air brakes. If we like shoot a little under what we simmed. But we'd still be happy with that because we'd still be around our altitude. So
Okay.
Yeah.
So basically just overall weight essentially is your worry. Which it should be because rockets tend to gain weight as they get built.
Yep.
Definitely.
So, and I'm going to ask your flyer of record actually. Is there anything that keeps you awake about this?
Probably getting the inspection and feeling that, did I meet my expectations, for the team to follow suit. And in this inspection here, this team did double fold what they did last year, as far as answering questions and as far as articulating the terminology for the rockets and that. They've learned a ton. So I give them good kudos for it. Yes, I will work with them. The thing that bothers me are the switches. Put the lockout bar in it. Battery usage and power consumption, that bothers me too. And I'm going to make sure they get that accomplished. I will be out with them with the flight test, so we'll be going through all the checklists and to that full degree.
Okay. So I'm going to look up what I need to put down. So like I said, the things I'm going to flag basically are unable to verify some of the battery mountings and the wiring on the sleds, and the recovery system installation. You haven't done your ejection test yet. So those are the risks I see on the rocket.
okay.
And other than that, I very much appreciate you having your PowerPoint. That was very helpful and having the rocket actually. But that was very helpful to see what you got there. And I call this a good review.
Okay, thank you.
Perfect.
So I will see you folks in about a month and a half,
Hey,
and wish you the best of luck out there.
Yeah, can't wait.
thank you.
Thank you so much for your time.
All right, take it easy now.
Thank you, Steve.
Bye-bye.
Bye.
Okay, I'm going to leave the meeting now.
Stop recording. Or are you on?
Stop.
Talking with Frank.